Today I'm going to talk about the use of nanoparticle containing admixtures for concrete with lower carbon footprint. Here. So let me talk first about sustainability and concrete production. For UN definition, sustainable developments are development that meet our need without compromising future generations. And we know that concrete plays a vital part in construction, but production of cement processes a CO2 emission. This is well known. Therefore, we need to reduce emission, natural resources, and energy in concrete production and construction. Okay. So at Master Builders Solutions, we develop innovative patented CHH containing admixtures. We also call that Master Exceed families. Okay? And that increase both early and late strength for concrete and further enhance the use of higher supplementary materials, reduction of cementitious materials, reduction of energy need for curings, reduction of time for demolding, shipping, while increasing productivity and construction speed. Okay. Of course, also we want to achieve the the cost efficiency. So therefore, the CHH containing admixtures contribute to sustainability and reduce emission, natural resources, and energy. So I'm going to talk about how can we do that. So as you can see here that the admixtures can enhance strength significantly for concrete mixtures with high supplementary materials. In this case that we have 30%, 40%, and 50% fly ash. And you can see that the increase of strength is from 24 up to about 60%, okay? And at 28 days and also at 1 day, including your 7 days. You can see that. The other case that when we have 65% slag, for example, the increased strength at 1 day is 65%. At 28 days, 28%. Also at 7 days was high. For the case that we're using 35% mill limestone with the admixtures, we can increase the strength at 1 day 45% and at 28 days 24%. So it's very significantly. So the CHH containing admixtures increase significantly early and late strength of mixtures with high content of supplementary materials. Okay. So I want to show here that the admixtures can increase strength for diverse concrete mixtures with supplementary materials. In this case, that the everyday make with the water cement ratio 0.53, and you can see that the increase of strength at 28 days about 1,000 psi. Also, it was increased at 1 day and 7 days. Or for the case of mid-strength mix, when we have water cement ratio 0.45, again, that on 20 days, we get almost 1,400 psi increase, also significantly at 7 days and 1 day. Or in the case that for high-performance concrete, when we have water cement ratio 0.25 and supplementary materials almost 60%, the increased strength at 28 days and 56 days about 2,000 psi. In short, we can say that CHH containing admixtures increase significantly early and late strength of diverse concrete mixtures with medium and high supplementary materials contents. So in the case that if we don't use supplementary material content, what happens also if you use air entraining admixtures, okay? So you can see that in this case that without supplementary materials, water cement ratio 0.56, also again that strength enhancement in more than 1,000 psi at 28 days, also works significantly at 7 days and at 1 day. Or in the case that we have water cement ratio 0.46, again that's a strength enhancement in more than 1,000 psi at 28 days, and then it is good also 1 day and 7 days. In the case of for the air entraining concrete, you see that the increase of strength is significantly, okay, at 1 day, 7 days, 28 days, 56 days, and 84 days, almost 2,000 psi. So again, we want to state it that CH8 containing admixtures increase significantly early and late age strength for diverse concrete mixture with and without air entraining. Okay, so we know that it increased strength, right? How we are going to do that? So we are going to reduce the total cementitious materials. Okay, so in this case, that you can see that with the cement only, we are able to reduce 50 pounds, 75 pounds, 100 pounds of cement, and we still can achieve similar or slightly higher strength at 1 day, 7 days, 20 days. So 50 pounds, 75 pounds, 100 pounds per cubic yard. It means that about 30 pounds up to, 30 kilograms up to 60 kilograms per cubic meters. Okay. So in the case that with 15% flash, again, that in this case that we can, also, in the first case, the water cement ratio was higher, okay? We increased it higher compared with the conference mix. Okay. So similar here, we also increase higher water cement ratio and reduce the cement content of 80 and 88 pounds per cubic yard. Again, that you can see that we get a similar or slightly higher strength at 1 day, 7 days, and 20 days for 15% fly ash mixes. For the case that with 15% slag, you can see here that again that we increase higher water cement ratio compared with reference mix, and we were to reduce 50 pounds, 75 pounds, and 100 pounds per cubic yard of total cementitious materials. And we are able to achieve similar strength at 1 day up to 90 days. It keeps going, okay? We have also testing at 1 year. It's still good, okay? So we can say that CH8 containing admixtures enhance high reduction of cementitious materials, typically from 50 up to 100 pounds per cubic yard. So therefore, it can reduce CO2 footprint, okay, significantly. For example, we can reduce 1 ton of CO2 if we use 20 cubic yard of concrete with cement reduction 100 pounds. So it's significant, okay. You need only 20 cubic yard of the concrete with these admixtures. We are able to reduce 1 ton CO2. Okay. So, and we know that it enhancement. How about the early strength? Okay. So this is case for precast application, for example. So you can see that for when using these admixtures, we can increase the high early strength at 16 hours with type 1-2 cement. See that in the first case that we can increase about 1,300 psi at 16 hours. Okay. In the second case, when we have low cements, the increase about 1,000, almost 1,000 psi at 16 hours. Okay. Or in the case that we want to achieve high ultra early strength, okay, at 4 hours or at 8 hours. So we can increase the production, the ship, okay? Instead of one ship, you can have two ships, for example. Or maybe you can open for traffic early, 4 hours or 8 hours, you already can open for it. So in this case, for example, at 8 hours, even that we are entering in concrete, we can achieve almost 8,000 psi. Of course, in this case, we have using type 3 cement and no heat curing. Okay. So in the case that we have 4 hours, for example, we can achieve 3,300 psi or 1,500 psi at 4 hours, depend on the admixtures dosage. So we can conclude that CSH containing admixture enhance high early and high ultra early strength without heat curing. It's increased productivity, it means that more ship per day, or can increase construction speed. Certainly that it contributes CO2 footprint reduction due to non-heat curing. So recently, in the US, we're starting to use type 1L cements. Type 1L cement is integral of limestone together with ordinary Portland clinkers. Okay, so we want to see if this admixture work with type 1L cement or not. Okay, so you can see that in this case, with or without flash, with type 1L cements, with these admixtures, we still can achieve very high strength at 8 hours. You can see here that at 70 degrees in cooler, at 90 degrees, or at heat curing, you can achieve very high strength. See, more than 3,000 without heat curing, 4,000 with cooler, and of course, when we have the heat going there, we get more. Okay? So, also, we want to see, okay, can we still able to reduce the cement? Type 1L cement? Yes, we can. As you can see here, in this case, the mixture have 18% flash. With type 1L cement, we have to reduce 50 pounds, 75 pounds, and 94 pounds with higher water cement ratio compared with reference mix, okay? And we still achieve similar strength at 1 day, 7 days, and 20 days. In the case that with no flash, again, similar. We can reduce 50 pounds, 75 pounds, and 94 pounds with higher water to cement ratios, and we achieve similar or higher strength at 1 day, 7 days, and 20 days. So we can conclude that CSH and CSH containing admixture enhance a high ultra early strength with type 1L cement with or without flash. Or it can enhance high reduction of type 1L cement and supplementary materials. So let me make a summary. The innovative patented CSH containing admixtures, or we call that master exit family, increase both early late strength of concrete and enhancing in using higher supplementary materials, reducing total cementitious materials, reducing energy for curings, reducing time for demolding, shipping, and increasing productivity, as well as construction speed, and of course, we can achieve cost efficiency. And at the final, the CSH containing admixture can contribute to sustainability and reduce emission, natural resources, and energy. Thank you very much for your attention.